Sketching transformations of parent functions using the image mapping of key points. I'd like to give a sketch of this function, f at x equals negative 1/4 times the square root of 2x plus 4 and then minus 5. This is my a value, and this indicates that it is a vertical compression, and it's also a reflection in the x-axis. That's my k value, and since it's a 2, it means it's going to be a horizontal compression. This is my d, and that's my c. Before I go any farther, I have to adjust things. I have to take out the k value as a common factor. So I'm going to write this as negative 1/4 square root of 2 times x plus 2 and then minus 5. That's because functions are always defined as x minus d, so I've got to have a 1x here. This tells me that my adjustment in terms of a horizontal compression will be 1/2 times x. So for a root function, my key points are 0, 0, 1, 1, 4, 2, and 9, 3. Looking back at this function, I'm now going to take out what transformations I'm going to apply to the x and the y. I've got negative 1/4 times that, which means that the negative 1/4 is an a value. It changes the y's. So I'm going to multiply all my y values by negative 1/4. I will also subtract 5 from all my y values because that's my c. For x, I'm going to do the opposite to what's inside the bracket. So instead of a plus, I'm going to do minus. So I'm going to do minus 2, and since I have a 2 for a k value, I'm going to multiply by 1 over k, so it's going to be 1/2 x. Now I'm just going to start substituting in my key points. So for my x coordinate of the new point, I'm going to take 1/2 of 0, minus 2, gives me minus 2. Negative 1/4 of 0 is 0, minus 5 is negative 5. For 1, 1, 1/2 times 1 is 1/2. 1/2 minus 2 is negative 1 and 1/2. And then negative 1/4 times 1 is negative 1/4, minus 5 is negative 5 and 1/4. For the 4, 2, 1/2 times 4 is 2. 2 minus 2 is 0. And then for the y, negative 1/4 times 2 is negative 1/2. Minus 5 is negative 5 and 1/2. And then for 9, 3, 9 over 2 is 4.5. 4.5 minus 2 is 2 and 1/2. And for the y's, negative 1/4 times 3 is negative 3/4. Minus 5 is negative 5 and 3/4. Now I will just plot these points. So I have negative 2, negative 5, which is right here. Negative 1.5, negative 5.25. Negative 1.5, negative 5.25. 0, negative 5.5. And then 2.5, negative 5 3/4. 2.5, negative 5 3/4. So my graph looks like this. If we look back, we had a vertical compression that was reflected in the x-axis. So the parent function of this guy would be up here. So a basic root function looks like that. It has been reflected in the y-axis, and then it has been vertically compressed. It's been shifted to the left by 2, and it's been shifted down by 5. Next one. We're now going to do f at x equals 2 times negative x plus 6 squared plus 3. I'd Again, before I do anything, I have to take out this negative number in front of the x. I have to have just an x inside the bracket. So this can be written as negative 2 times negative x minus 6 squared plus 3. The negative 2 tells me I'll have a vertical stretch by a factor of 2, and it will be reflected in the x-axis. So this will be negative 2y and then plus 3. The negative sign tells me that I will have a reflection in the y-axis, and the minus 6 tells me I'm going to add 6. I'm going to do the opposite to what is there. Now I'll use my key points, and for a quadratic I'll use negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. I use these points because these are the basic points for an x squared function that is centered at 0, 0. That's your parent function for x squared. So this is going to be a transformed version of that. So now we just plug in the points. For my new x, I'm going to say negative of negative 2, which is 2 plus 6 gives me an 8. And for the y, I've got negative 2 times 4, which is negative 8, plus 3 is negative 5. For negative 1, I say negative 1 times negative 1 is 1, plus 6 is 7. And then negative 2 times 1 is negative 2, plus 3 is 1. Sorry, that's, yes. And then 0, 0, 0 plus 6 is 6. And 0 plus 3 is 3. Then I will have, for 1, 1, I will have negative 1 plus 6 is 5. And negative 2 plus 3 is 1. And then for 2, 4, negative 2 plus 6 is 4. And negative 8 plus 3 is negative 5. Now, one way I can be sure that I've done this correctly is if I look at my y values, they're symmetrical. Negative 5, 1, 1, 3. Now I'll just plot them. So we will have 8, negative 5. So 8, negative 5. 7, 1. 7, 1. That should be up there. 7, 1, 6, 3, 5, 1, and 4, negative 5. So this one should not be there. And here is my transformed function. Okay. Parent function, transform function, reflected in the y-axis, reflected in the x-axis. One more. Let's look at a reciprocal function. F at x equals negative 4 over x minus 3 minus 7. My key points for a reciprocal function are 1, 1 and negative 1, negative 1. This negative 4 on top, that's like negative 4 times 1 over x minus 3, so my a value is negative 4. So I'm going to say negative 4 times y and then minus 7. For my x values, I'm just going to do x plus 3. I'm just going to do the opposite of what's in the denominator. Now I plug in my points. 1 plus 3 is 4. Negative 4 times 1 is negative 4. Minus 7 is negative 11. Negative 1 plus 3 is 2. And negative 4 times negative 1 is 4. 4 minus 7 is negative 3. To make it easier for myself to visualize this, I'm going to draw in my asymptotes. My asymptotes are at x equals 3 and y equals negative 7. So x equals 3 is right here. And y equals negative 7 is right here. Now I will just plot my points. So I have 4 comma negative 11, 4, negative 11, and 2, negative 3. My graph looks like this. Now you know it's a horizontal, you know it's a vertical stretch because the original, the standard parent function would have my asymptotes would be there and there, not those guys, and they would go like this. It's a stretch because what was originally at 1 is now down 4. What was originally at negative 1 is now up there. And it's all been shifted. Came down by 4. There's your 4. So that is how you transform parent functions. Thank you for watching this video.